This video will provide a brief overview of the concept of ratio controllers in the chemical engineering industry. It will cover what ratio control is, how it works, and common uses of ratio controllers in industry. Ratio controllers are typically used to maintain constant mixtures of compounds within a process to ensure that proper specifications for products are met. They are used frequently in industry for a variety of purposes and help a chemical plant to run economically and meet environmental regulations. This figure shows a typical ratio control that adjusts the flow rate of one stream based on another. The top stream is known as the wild stream. This is because its flow rate is not maintained by the ratio controller. The bottom stream is controlled stream and is fitted with a control valve to adjust the flow rate as needed. As the two streams prepare to form the blended flow, the flow indicators, FI1 and FI2, read the flow rates and compare the ratio of them to a set value that is desired. If the ratio is not correct, the FIC controller adjusts the setting of the control valve to change the flow rate of the bottom stream until the desired ratio is met. Another way that a ratio controller is used is to adjust the power available to heaters in order to attempt to maintain a steady outlet temperature. The flow transmitter measures the rate of the fluid and sends a signal to the power controller. This adjusts the amount of power sent to the heater based on a ratio that has been set. This allows larger flow rates to get the amount of heat needed to increase their temperature if the stream is increased due to an earlier upset in the process. One common use of a ratio controller is in the operation of combustion furnaces within a chemical facility. It is important to control the ratio of air to fuel within a combustion furnace, as it has both economic and environmental impacts. If not enough air is fed to the furnace, the fuel will not completely combust. This allows excess fuel to be released to the atmosphere through the stack gases. In addition, when the fuel is not completely combusted, it forms carbon monoxide instead of carbon dioxide. This is a major environmental issue. On the other hand, if there is too much air present, the heat created from the combustion will simply be used to heat the excess air rather than the chemicals within the process. This is economically unfavorable because you are wasting valuable energy. Another common use for ratio control is within petroleum refineries. Specifically, it is a necessary aspect for the production of gasoline. In this case, the wild feed is the gasoline because differing feed conditions at the beginning of the process can create different amounts and qualities of gasoline. Typically, the gasoline produced in a refinery is not a high enough quality to be used within motor vehicles. An octane boosting system is controlled in order to mix the necessary amount of additive into the fuel to make it a marketable product. Ratio controllers allow a process to handle varying flow rates and compositions of product while still being able to meet product specifications and environmental regulations. They are a very common fixture in a variety of industries, and without them, it would not be possible to create consistent products at a marketable standard.